Okay. Now, welcome to all. Today we'll discuss about definition of relation. First, we'll discuss about this order pair. Order pair we know in coordinate geometry we have seen the order pairs how they will be. Okay, some two elements, two numbers you can write in a order as a comma b. We say it as order pair. Okay, order pair is nothing but it is a point on the Cartesian plane C, like 2 comma 3, 3 comma 2, like that. 1 minute. Now sets we know. Set is a collection of well-defined objects. Now we'll see the difference between order pair and sets. See, by the very definition, order means we have to write in order, no ascending or descending order. By the very definition itself, we can say a comma b is not equal to b comma a, because 2 comma 3 and 3 comma 2 will represent a different position. They are not same unless both a and b are equal. See, whereas in sets a comma b or b comma a both are same, 1 comma 2 or 2 comma 1 both are same in sets. And one more thing, in order pair a comma a is an order pair. 2 comma 2 will represent 1 point, 3 comma 3 will represent 1 point. We have learned that each and every point will represent a unique point in the Cartesian plane. Whereas in sets 1 comma 1 you can't write elements. Repetition is not allowed in sets. Instead of 1 comma 1 or a comma a, you can simply write a itself. That is the difference between order pair and sets. Now we'll come to the one more thing. When two order pairs will be equal means if their first coordinates are equal and the second coordinates are equal. Here see, 1 minute. Here y is the first coordinate or first element. In this order pair, x is the first coordinate. So y should be equal to x. And here, what is the second coordinate? X minus 2 is there. Here, second coordinate is 0. X minus 2 should be equal to 0. Then only we can say that these two order pairs are equal. If you simplify, no, x minus 2 is 0 means x you will get 2 and y is equals to x, no, y also will get 2. Then only these two order pairs are equal. Okay. This you can use as a formula and you can solve some problems. Next, we'll come to the definition of Cartesian product. We have to take two set of elements, A and B, two set of elements we have to take. And we have to write all possible order pairs. How we have to write the order pairs? This first coordinate or we will take from the first set A, and that B will take it from second coordinate, will take from the set B. Then you can write the Cartesian product of A and B, and it is denoted like this. A cross B it is read as A cross B. Okay, we'll give some examples, then you'll understand much better. I have taken two sets, A 2 comma 4, B 1 2 3 elements are there. A cross B I can write like this. 2 comma 4 cross 1 comma 2, 1 2 3. First you can pair with 2. 2 comma 1, 2 comma 2, 2 comma 3. Next I have to pair with 4. 4 comma 1, one order pair. 4 comma 2, another order pair. 4 comma 3, another order pair. I have to write all possible order pairs. That is the Cartesian product. All possible order pairs I have to pair. If you write B cross A, that is different. See, first I have to take 1 2 3 elements, B elements. Second I have to take 2 4 elements. Now I have to pair. I have to take the first coordinate from B and second coordinate from A. 1 comma 2, 1 comma 4. Next I have to pair with 2. 2 comma 2, 2 comma 4, 3 comma 2, 3 comma 4, like that. See, in general, A cross B and B cross A are not equal. To understand much better, I will present this Cartesian product in different forms. A cross B there, no, this only I will present. First I will present with arrow diagram. I have to write like this. First set A, I took 2 and 4 elements. Next set 1 2 3 elements are there. That is set B. Now I have to write the order pairs. I will pair. See how I will pair. that relation, no, not it is a relation, it is Cartesian product. In place of R, you can write A cross B. 2, comma 1, 2, comma 2, 2, comma 3. I can write all these order pairs. Next, I'll pair with 4. 4, comma 1, 4, comma 2, 4, comma 3. All these order pairs I wrote. Next, we'll write the same thing in tree diagram. In first branch, you will be having the elements of first set, that is 2 and 4. In second branch, we'll pair these elements to the elements in second set, that is B. 1, 2, 3 will pair. 2, comma 1, 2, comma 2, 2, comma 3. Next, we'll pair to another branch also. 4, comma 1, 4, comma 2, 4, comma 3. To understand much better, I will do the graphical representation of A cross B and B cross A. I took the graph here. X-axis horizontal line, vertical line is y-axis, where they intersect is origin. Now we'll represent these order pairs on them. We already told no order pairs means it represents a point on the Cartesian plane if they are numbers. Now I'll represent 2, comma 1. How will you represent 2, comma 1? X coordinate you have to search 2. From there you have to go for 1. 2, comma 1. Next I'll represent 2, comma 2. 2, comma 3. What and all order pairs are there? 4, comma 1 is there. So next 4, comma 1, 4, comma 2, 4, comma 3 I'll represent. We told A cross B and B cross A are not equal. Now I'll show by graphical presentation. In that, what and all order pairs are there? 1, comma 2, 1, comma 4, 2, comma 2, 2, comma 4. And next what we are having, that one, another 3, comma 2 is there and 3, comma 4 is there. Are they same? A cross B and B cross A are same. See the points. A cross B, different set of points are there. B cross A, different set of points are there. Isn't it? So A cross B will not be equal to B cross A. It is very clear, I think. Next, we'll come to the definition of relation. Relation in general is the way in which two or more people or things are connected. Family, many relations will be there, no? Family relations are very important. To show that how much they are important, I'm showing one beautiful picture made by my daughter, Rishika Kameshwar, with a nice quote. See, family is where life begins and love never ends. See, in real life also some relations are very famous, like Lakshmana is brother of Rama. If we see some two good brothers, we'll say they are like Ram Lakshman. Parvati is wife of Parmeshwara. Panchali is sister of Krishna. See, actually Subhadra is sister of Krishna. But why this Panchali is well known as a sister of Krishna? Why? Because means Krishna saved her from disrespect. I'm not talking about religion. I'm just talking about the culture. Whoever respect or saves the girl or woman, they are God. Okay. Similarly, Ganesh is son of Gauri. Even their festival will celebrate together. Ganesh, Gauri, Abba will say. In mathematics also, we are having some relations. That is A is equal to B. P is equal to is one relation. X is greater than Y is one relation. Line L is parallel to line M. E is parallel to is one relation. E is perpendicular to is one relation. Okay. Triangle ABC is congruent to triangle DEF. That is one relation. Set A is subset of set B. This we'll discuss in set chapter. See, this relation, sometimes we can use symbols like less than, greater than, or equal to, be equal to symbol and parallel to symbol. So many symbols are there. Or in general, we can denote with R. That is enough. We can denote with the R. Okay. If A and B are in relation R, we can write like that. A is related to B or A comma B belongs to R. Okay, relation you can write like that. I will discuss more examples, illustrations also I will tell. This is just examples of relation. See, E is greater than one relation we took. 5 and 3 elements we check. 5 is related to 3 or not, we'll check. 5 is greater than 3, no ma? It is true. Then what we can say? 5 comma 3 belongs to this R. This symbol belongs to C. Like this, if you write, it is belongs to C. Next, 3 and 5 are related or not, we'll see. Is 3 greater than 5? No, which is not 2. Therefore, what we can say, this order pair 3 comma 5, this symbol is does not belongs to R. Okay. Now we'll do illustrations. Then you will understand much better. Now I'll write some relation from A into A itself. A, I took some 3 elements, 1, 2, 3 like that. I'll write relation from A into A itself. First, we have to take the Cartesian product. Cartesian product we have to discuss. We already discussed. We have to write all possible order pairs we have to write. Okay, total how many elements you will get? Here 3, here 3. 3 into 3, 9 order pairs you will get. See. Cartesian product is nothing but set of all order pairs. Now I took one relation. 1 comma 1, 2 comma 2, 3 comma 3, like that relation I took. Here, first coordinate and second coordinate, how they are related, see. How they are related, you can say by, that will give the formula for this relation. See. That will give formula for this relation. Here first coordinate and second coordinate are equal. Second coordinate and here also first and second coordinates are equal. So what we can say, how this relation we can write? We can write in another form also that we'll call set builder form. We have to take order pairs x comma y such that this x comma y is in Cartesian product A cross A. What kind of elements you have to take? We have to take elements whose first coordinate and second coordinate are equal. This is the formula. This is the another way to write this relation. Okay. This is called, if you list the elements like this, it is called Rooster form. If you write the formula like this, it is called set builder form. Few more relations will write. And here we have to talk what is the domain. Set of all first coordinates of the members of R1 are called domain. And range means set of all second coordinates of the members of R1 are called domain. Here, domain and A are same, range and A are same, but they may not be same in all ways. We'll discuss one more example, then you will come to know. Here one more relation I took, R2. Here see, first coordinate and second coordinate you observe. First coordinate is smaller than second coordinate. Here also same. What you can write? First coordinate will denote with x, second coordinate with y, no? You can write that x is lesser than y. That is the formula. So set builder form, how will you write? We'll take all order pairs from A cross B so that first coordinate is less than y. Such order pairs only will take in the second relation. And second relation you can name it as is less than. Here domain you see. What are the first coordinates? Here 1, here 1, here 2. 1 no need to write repeatedly. If you write one time it is enough. So 1 comma 2 only are there, domain. Range you see. Range means is second coordinates you have to see. Here what and all second coordinates are there, see. First order pair 2 is there, second order pair 3, third order pair 3, 2 comma 3. Here see, domain and A are not same. Even range and A are also not same, see. They are different. They may not be same always, I told no. One more relation I will take. I have taken in A, I have taken integers from -3 to 3. In B, I took square numbers 1 to 9. Okay, I want to write a relation R3 from A into B. Order pairs, I have paired all these elements. If you observe, no, this, how it is? If you do square root of second coordinate, you will get this value. Square root of 9 is not only 3. Square root of 9 is -3 also. We told it will be having 2 roots. Similarly, square root of 4, 2. Square root of 1 is 1. Square root of 0 is 0. Okay, here what is the formula? Formula also I wrote, see. We'll take order pairs such that order pairs will be contained in cross product A cross B. And what is the formula I told? How the first coordinate is? First coordinate is root of the second coordinates. So x equal to root y. That is the formula, see. Next, one more illustration. Here domain is all integers from -3 to 3 and range is square numbers 1 to 9. Now one more relation I wrote. I took the elements in set A 2, 3, 4, 5. In set B I took 3, 6, 7, 9 like that. Now I'll write order pairs R4, 2, 6, 2, 10, 3, 3, 3, 9, 5, 10. And what is the formula you see? The first element, how it is? First element divides the second element. See, 2 divides 6. Okay. 2 divides 10. 3 divides 3. 3 divides 6. 5 divides 10. Here first coordinate is dividing second coordinate. Or you can tell like this also. Second coordinate is multiple of first coordinate. Like that also you can tell. Here domain, if you take first coordinates, you take first coordinates of all order pairs, you take 2, 3 and 5 is there. And range, if you take second coordinates, what and all you are having? 6 we are having, 10 you are having, and 3 we are having. See here what is missing? In domain we are missing 4. Why? Because 4 cannot divide any of these numbers, see. And in range what is missing? 7. 7 is not multiple of any of this number. That's why 7 is missing in range. It's formula how you can give x divides y, like that you can give. Okay, these are the illustrations about relation. Now we'll talk about inverse relation. First we'll give the definition. Cross product, you know, we have to take two sets A and B. Cross products, how will you define? A cross B, we have to take all possible order pairs like this, whose first coordinate will take from first set and second coordinate will take from second set. And every relation you have already see the illustration. You have seen the illustration. Every relation is set of order pairs. That means a relation can be subset of some Cartesian product. So relation we can tell like this. R is a relation from A into B if and only if R is subset of A cross B. That means you can take some elements from A cross B. Next, relation A into A also we discussed. Is equal to, is less than we discussed. Okay, this how we can define R is subset of A cross A, you can tell. Now inverse relation, how will you tell? See, a relation, R is a relation. If R is a relation from set A into set B, then if you interchange the first and second coordinates of the order pair of R, we'll get a new relation from set B to set A. That relation we'll call it as inverse relations. And it is denoted with R inverse and it is given by like this. You have to take the order pairs y comma x. If x comma y belongs to R, you have in this what you have to take in inverse, you have to take y comma x. We'll give some example. R2 relation you have given, no? How is less than you told. 1 comma 2, 1 comma 3, 2 comma 3. If you interchange the first and second coordinates, what you will get in R inverse? You will get 2 comma 1, 3 comma 1 and 3 comma 2. If you observe the relation, what happens? If R defines is less than relation, then R inverse will define is greater than C. Similarly, one more relation. R3 we took, no? R3 what and all, how we took? How the order pairs are there? We have took like this. See, x will be the under root of y coordinate. If you interchange the order pairs, what you will get? 9 comma minus 3. If you interchange the second one, 4 comma minus 2, third one, 1 comma minus 1, 0 comma 0, 1 comma 1, 4 comma 2, 9 comma 3. Now what happened to relation? If R3 is defined from A to B, R inverse will be defined from B to AC. And how the relation is changed? E's square root is there earlier. Now it became E's square of. If you try to find inverse, R inverse, it became E's square of C. To understand relation and inverse of relation, we gave these illustrations. Okay. Please mail us to ssudhirkuma@gmail.com for more videos. This is okay. Now, 1 minute, I'll stop sharing. And one more thing, even recording also I have to complete. But that's all for today. Bye. See you tomorrow.